This PowerPoint involves the solving of trigonometric equations. We'll be doing three ways: graphically, explaining how using graphs to do this. As we've seen in the past, graphs is not an accurate method. We'll show you a method how to do it algebraically, and finally we'll show you how to use our calculators to do this. So when you're ready, proceed to the next slide. Here we're asked to solve for x, and where the equation is sine of x is equal to 0.6, and we're asked to do it between 0 and 360. So this is a graphical method. So the first thing we do is graph the function y equals sine x. We already have this drawn in our notes. So here the blue graph here is the graph that we want. That's y equals sine x. You see at 90 degrees it gets up to 1, 270 down to -1, and back to the theta axis or the x-axis at 360 degrees. And we're asked when it equals 0.6. So what we do is we now draw a horizontal line representing the equation y equals 0.6. And what we're trying to do is find where these two graphs intersect. So the red dotted graph is y equals 0.6 and the blue graph is sine. So we go down here, we're asked the values of x or the values of theta, where answers here. So if you look at the scale here, it looks like this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 degrees, so it looks like it's somewhere between 30 degrees, which is there, and 40 degrees. So we estimate it, we can see here we've estimated it's about 37 degrees. But with sine and cos graphs and tan as well, we can find sometimes there's more than one answer, depending on what domain we're asked to look at here. And the domain here says we want to find all the x values between 0 and 360 that answer this equation. So we can actually see there's a second time, because sine is positive in both in the first and second quadrants. You might remember from our unit circle that we have this, that all students talk consistently. So sine is positive in the first two quadrants. So there's going to be two times where sine is equal to positive 0.6. And we can see from the graph this is true. This is 100, 110, 120, 130, 140, between 140 and 150. And we can estimate that as 143. In fact, there's a relationship between these two numbers. What is it? Yes, adds up to 180, doesn't it? Alright, so that would be the graphical method. As you can see, this method is limited by we've got to estimate whereabouts this here. So at the best, we're only getting an approximate answer. So that's the key thing here. We're only approximately equal to those two things. So it's not necessarily the preferred method of how to solve this. Later on, we'll see how we can use our calculator to get the exact answers. So when you're ready, we'll proceed to the next slide. Okay, and here we have two problems we need to solve, so I'm just going to separate the page. Alright, if we're asked to solve it in algebraic method, there's a distinct method that we want to use here to solve these problems. We break it up 3 steps. The first step is we determine where we're going to find these answers, what quadrants. As we saw in the previous thing with the graph, we can have more than one answer. So what I look here is I go, well, the function I'm dealing with sine, and also here that it's a positive answer. Now I know that sine is found to be positive in the first quadrant and the second quadrant. So I'm going to find two answers, and they're going to be in the first quadrant and the second quadrant. So we determine where we're going to find the answers first. The second step is to find what angle we're going to be talking about here. Sometimes we call this the base angle. So we work up on the angle. And what we look at here is we go, well, the function here is sine, and we look at what value it is. Oh, it's √3 on 2. If we remember our exact values, that's sine and √3 on 2, the angle we're talking about here is 60 degrees. Alright, the third thing is we put all this together, and it helps us to think about our unit circle. So I'm just going to draw a little unit circle down here. So it looks like this. Probably should have made it a bit bigger actually. I might make it a bit bigger. Let's make a nice big unit circle for that axis. I might extend the axis now. Alright, that's going to make it a bit better for us to see. Alright, so what we're actually finding here is we said there's one answer here in the first quadrant when the angle is 60 degrees, that the sine value is root 3 on 2, this length here, this length here. Now, there is a matching angle over here which has the same height. Right, where is it? It's 60 degrees from the x-axis this side, so we always work from the x-axis, so the same angle. So this is 60 degrees this way, this is 60 degrees this way. So my two answers, using that as a guide, my two answers I'm going to get here, because I said there's going to be one answer. The answer in the first quadrant is 60 degrees. In the second quadrant, I don't know why I've got that there, just get rid of that. Okay, in the second quadrant it's going to be 180 degrees minus this angle of 60 degrees. Why is that? Because what's the value on this line here? I'm at 180 degrees and I've got to go back this way, so I've got to subtract. And so my two answers are going to be 60 degrees, and 180 minus 60 is 120 degrees. And of course we can check those answers by putting those back into the original rule. Sine of 60 degrees is root 3 on 2. Sine of 120 degrees, you might need your calculator to do that, and also because root 3 on 2. Remember, we're solving this problem between 0 and 360. Sine is only positive in quadrants 1 and 2, so we'll have two answers there. If we drew the sine graph, which looks like this, we know this point here is at 180, and root that goes the height of 1 goes down to -1. Root 3 on 2 is about 0.87, so we're looking at this horizontal line here, so we're talking about the graph intersects here and here. Alright, that's how we'd solve that. In a moment we'll show how we can use our calculators to solve this as well. But let's do part B first. Now this one here asks us to solve where sine of 2x, notice the 2 in there, is equal to this for 0 to 360. Now it's worth us to consider what the graph looks like here. Before, on our previous, when we were doing graphs, we actually drew the graph of cos equals y equals cos of 2x and looked like this up to 360. Well, I hope it looked a lot better than that. Okay, we found that it repeated twice at a period of 180 degrees, so that there was at 180. Okay, now we're asked where this graph equals -1 on root 2, which is approximately -0.7. So that's down here. So when I draw that graph across here, I can actually see I've got 4 answers between 0 and 360. So what we need to do is work out a method that's going to work for this. So when we have a number here in front of the x, what we do is we say we actually need to work this answer out between 0 and 720 degrees. Right, but we're sort of changing the letter to A. So we're basically saying here that A is equal to 2x. How do I get 720? What I do is I multiply 2 by both the original numbers up here, 0 and 360. Alright, so now we go through the same method as the previous one. The first thing we work out what quadrants we're going to expect to see these answers. So it's cosine and it's a negative answer. We know we get cosines negative in the second and third quadrant. But as I go around my circle, to get to 720 degrees, I've got to go around the circle once. So that's quadrants 1, 2, 3, and 4. But then I've got to go around a second time to get to 720. So this would be quadrants 5, 6, 7, and 8. So we've actually got 2 more quadrants where cos is negative, where x is negative, which is in this section here. This section here, so that, and that. Quadrants 2, 3, 6, and 7. Okay, the second thing we talk about is the angle that we need to work with here. We've got cosine, and we have negative. Oh, we've already dealt with the negative, so we just look at 1 on root 2. If you remember your exact values from before, cos 1 root 2 makes 1 root 2 is 45 degrees. And the last thing is we put all this together. So we're talking about A. In the second quadrant, it's going to be 180 minus 45. The third quadrant, I start at the x-axis, I'm at 180, but I've got to add 45. Quadrant 6, where am I at quadrant 6? Well, if I go around the circle once, it's 360 degrees, plus 90, 450, plus another 90, I'm actually at 540 degrees when I'm talking about the 6th quadrant or the 7th quadrant. So it's going to be 540 minus 45 for the 6th quadrant, and 540 plus 45 for the 7th quadrant. Minus because when I go into the 2nd and 6th quadrant, I'm going backwards, that's a negative direction. When I go into the 3rd or 7th quadrant, I'm going in the positive direction, so I add. So, just to make that point, so in the 2nd quadrant and the 6th quadrant, I've got to go backwards, so that's why I've subtracted 45 from where I am on the circle. And the 3rd quadrant and the 7th quadrant, they're over here, so I'm going in a positive direction, so I add 45 degrees. So what is this going to give me? A is equal to 135, 225, 495, and 585. But we weren't asked about A in the question, we were asked about X, and we said A is the same as 2X. So now we need to divide everything by 2. So here I get 67.5, 135 divided by 2. 225 divided by 2 is 112.5. 495 divided by 2 gives you 247.5. And 585 divided by 2 gives you 292.5. Okay. When we go to the next slide, we'll see a much neater version of all this. Without the graphs though, so you might want to come back and get the graphs. We'll stop there. Okay, I'm going to go home and start a new document. Don't want to save that one. I'm going to start with a calculator page, and we are now going to learn about solving equations. The first example was a graphical example in the notes, but I'm now going to show you how we can use the solve command to do this on a calculator. If we go to algebra and select solve, if I type the first equation, which was sine of x is equal to 6 and type comma x. I'm going to get an answer that at this stage we won't understand what it means. It's more for Year 12 methods course and specialist. So you'll see it's got these funny N1s in here. Doesn't mean a lot to us. The reason is that there's lots and lots and lots of answers here. We haven't specified that we want our answer only between 0 and 360. So what we do is we go up and select the equation, then we use that separator thing from control equals, that line, and we say once again 0, control equals less than or equal to x, control equals less than or equal to 360. Now my calculator is probably in exact mode or auto mode, so I'm going to go control enter here, and you can see it gives me the answers here as x equals 36.8699 and x equals 143.13. If you look back at the answers we did on the graph, we said they were approximately 37 and 143 degrees. So our estimation from our graph was not too bad. Alright, the second example we did was sine of x equals root 3 on 2. So I'm a bit lazy, so I'm going to go and select this, and all I have to do is change this number in here. Because it's root 3 on 2, I'm going to go control divide, and I put on top the square root of 3 on 2, and we can see that's the equation we need to solve. If I press enter, it tells me the answers are 60 and 120 degrees, as we worked out. And the third one we had to do was solve where cos of 2x, so I need to change this. We can just type cos, but we want this to be 2x, and the value was -1, so I get rid of that, -1 on root 2. So I don't know if I do that changes. Yes, it does. And between 0 and 360, if I press enter, and you'll see I get 3 answers. It's given me in fraction form because my calculator is an auto, so if I go control enter, you can see I get the same 3 answers that we talked about: 67.5, 122.5, 112.5, 247.5, and 292.5. Alright, just while we're on this, I'd like to have a look at the graphs of these. So I'm going to go to doc and go insert a graphs page. Alright, the first rule here I'm going to look at here is sine of x. Did the wrong key. Sine of x, and I'm going to say it's between 0, I'm doing this quickly using my calculator, between 0 and 360. You can use those symbols if you type it from a keyboard. And remember, that's not going to show us the whole graph properly, so I'm going to change this to zoom trig, but I don't need all these numbers here, so I'll just make this 0, and I don't need to go up to 4, so I'll just go up to 2 and down to -2. Alright, so a bit better graph. Now we want to know when this is equal to root 3 on 2, so I go tab, and here I write exactly what that's equal to. Is square root of 3 on 2. Press enter. So that's where the graphs are intersecting here and here. I can ask the calculator to find those for me by going to the intersection. That's that and that. It tells me at 60 it equals to that value. Root 3 on 2 is 0.866, and the intersection between there and there tells me at 120 and 0.866, which is the same value as root 3 on 2, approximate value. So I can use the calculator there. I'm going to go to document and insert a new graphs page, and I'm now going to look at the graph of cosine of 2x, but I want to go between 0 and 360 again, so go through the menus and select all these values. Right, so that only gives me the graph 0 to 360, but once again it doesn't look like the graph I'm expecting because of the window I've got here. So I'm just going to change these manually. I'm going to make that 0. I'm going to make this 1.5, out to 360 down to negative 1.5. So I get an idea, it's a better idea what the graph of cos 2x looks like up to 360, going positive 1 down to negative 1, and press tab. The other graph that I'm looking here is negative 1 on root 2, so control divide. Here I write negative 1 on root 2. Press enter. So that's this purple graph down here. You can see that it intersects in 4 coordinates, so I'm now going to go to the analyze part of the menu and find where these intersections are. So it's there, menu, analyze, intersection, from there to there. Right, all the labels are getting in the way each over here, so I'll alternate these ones, one above, one below. Right, you notice that answer there is, it says 113. We know the answer to be 112.5. The calculator is only giving me to 3 decimal places. You can change this by clicking in here and going control menu. Oh no, sorry, not in. Just got to select it. I have trouble with this. Maybe it's gone multi-select now. There we go, it's selected, it's not inside the box. If you go control menu, go to attributes, it's saying it's only precision to 2 decimal places, so if I now change this to 4, for instance, press enter, it didn't do it for me. Great. Now I've got to go back to this, don't I? Oh. It's rounding that off, I can't, oh yeah. Attributes, I need to change that to more decimal places, so it's gone to 4. If I go to 5, won't make any difference. You see it's 112.5. Analyze the graph, intersection, here to here, going to get the same issue, menu, analyze graph, intersection, from here to here. It's overlapping again, so I'll put that one up above there. So you can see it's only giving the 3 significant figures, so I'm going to go attributes and change that to 4. I'll try and do this so you can see how you do it. So you go select on a control menu, control menu, no, control menu, attributes, and we need to change the precision. It's not doing that because for some reason it selects off it. Control menu, no. No, I can't do that very easily. So it's a limitation of the calculator. So that's why we should always use the calculate menu. Back here we can see the exact answers here. The calculator, the graphs thing might be rounding off answers, so you've got to be very wary of that. It's always a problem. I think at that point we'll leave that and proceed on the next slide and see which questions you need to do for this section.